Okay, this is what we are going to do today. It's about complex numbers and trigonometric identities using the Moivre theorem. So, excuse me. So that's what we're going to do. So this is it. So what do you know about complex numbers before I proceed? Normally, whenever it's a complex number, let me say Z is given by CC theta, right? Is that okay for everyone? That's easy. That's what you're going to talk about. So we will prove the some identities, sin x is, sin 2x, cos 2x, even sin 3x, sin 3x, and cos 3x using compound angles. So today we're going to prove some of them using the Moivre theorem. So what does the Moivre theorem say? So if I have this and then I'm looking for z power n, it will give me cc, okay, power n. So which means it ends up giving me, that's the Moivre theorem, cc n, sorry, a bit, okay, cc n theta. That is it. That is what the Moivre theorem says. I hope you're familiar with this. If you're not, we can do that one later. So there's no problem about that. Okay, so let us start and see. Okay. Click on. So for instance, this is the question. Let me start with this. So you are given by Z equals to this. This is what is given to you. And then they are saying you show that this one is equal to this. Definitely this one by using the Moivre theorem. So this is correct. So I would like to try to do this and see if you fully understand what I'm talking about. Okay, just a minute. So what do I have here? It's going to be, I have a Z equals to CC. Let me go with the expanded version of it. Okay, the expanded version is going to be cos theta plus I sin theta. Is that okay? Now, what's Z squared now? Z squared will be equal to cos theta, right? Squared by the normal way, binomial expansion, plus 2I sin theta or cos theta, doesn't matter, whatever I write first because it's multiplication. Okay, you get what I'm talking about here? Cos theta, then plus, this is what I want people to see, sorry, just a quick one. I sin theta squared. Okay, I hope that makes sense. Now, what do I get now? I'll get Z squared equals to cos theta squared, right? Plus 2I sin theta cos theta Now, what is I squared? I would like someone to pay attention here. What's I squared in trigonometry? I mean in the complex numbers. It's a -1, right? So what does that mean? Uh, it means this I squared will be equal to -1. So meaning here I'll get minus sin minus sin squared theta. Okay, now what have I got here now? I have got an expression of Z that has a real part and imaginary part. So what's Z squared now? I need to put the real part together and imaginary part. As you know, every complex number, for instance, if I say A plus BI, so this is your real part and this is your imaginary part. So meaning now I'll get cos C squared theta, okay, minus sin squared theta plus 2i sin theta, then cos theta, right? Is that okay? Where this is my real part, this is the real part of my complex number, then this is the imaginary part. Now back to what we did here. This one we got it using the Moivre theorem. So we know that using the Moivre theorem, z squared equals to cos 2 theta, right? Plus I sin 2 theta, right? Is that okay for everyone? Now, the real part of this, here I expanded using normal expansion, binomial expansion. And I have expanded this using the Moivre theorem. So the real part of this expansion, let me call it 1, and the expansion of this, the real part of it, they should be equal, right? So what does that mean? It means cos 2 theta, sorry, equals to cos squared theta minus sin squared theta, right? Is that okay for everyone? I've equated the real part, this to this. Now, what about these two? They should be equal as well, right? So, by the way, if you remember your trigonometry, this is the value of cos 2 theta when you prove this one using compound angle. So you're going to have this. So what about if I do the other one? So what about sin 2 theta now? Sin 2 theta is going to be equal to the i's are cancelling out, okay? Hence proved, right? You see that? So if you use, this is what you prove using compound angle formula. But right now you can prove that, you know. When I say compound angle formula, you guys you should remember that cos A, for instance, plus plus B should be equal to cos A cos B, right? Minus sin A, then sin B. So if this is what we are using in year 12 or DP1, that's what we are doing, right? So check if you use this one, you're going to have exactly the same as that. Okay, making sense? So I've already got this one and I've even proved the sin theta and this one. So come on, very easy. Let us go to the next one. I would like to prove this. That's the one I'm going to prove, okay? So keep this on your mind, note it down because I'm going to use it for the next question, okay? So what have we got? What did we have? We had sine 2 theta, sine 2 theta was 2 sine theta cos theta, right? Was that okay? Then what did we get as cos theta now? Cos 2 theta, sorry. So cos 2 theta is cos squared theta minus sine squared theta, right? Okay. Now, what about tan 2 theta? That's the one I want to get. Tan 2 theta. So tan 2 theta. Okay, I can go with compound formula, but let me go with that. Normally, tan 2 theta will be equal to sine 2 theta over cos 2 theta, right? Trigonometry, because we know that tan is sine of sine theta over cos theta, right? Okay, very good. Let us see what will happen. So from here now, tan 2 theta will be equal to, what is sine 2 theta? It is 2 sine theta cos theta, right? I'm saying here, let's check. I've replaced this here. So now over cos squared theta minus sine squared theta. Come on, is that okay? Making sense now? Okay, very good. Now, when you reach here and you want to express this one only in terms of cos or in terms of sine, so here we are talking about tan, it should be only in tan. So what do we do? Just check what I'm going to do. Divide. I'm going to divide everything by this. So let me do that one and you see what happens. So I'm going to have 2. Let me write cos theta first because it's multiplication, doesn't matter. Sine theta over cos squared theta. Is that okay? All of that over, because I'm dividing. Let me use a different color for you to see what I'm talking about. I'm dividing everything by cos squared theta. I'm dividing this one everywhere. And also divide it for this as well. Here. This one divided by cos squared theta, right? Okay, let me see if your trigonometry is good. So that means here I'll begin with 1 minus tan squared theta, right? Because sin theta over cos theta is tan. So they are squared, both of them. Now, what about here? This squared cancels out with that. What do I remain with? I'm going to remain with what? I'm going to remain with 2. This is sin theta over cos theta, so gives me tan theta, right? Okay. Over 1 minus tan squared theta. So hence proved. So we have been able to prove both of them. This time around using the Moivre theorem, which is very easy, and you can do it without using compound angles in trigonometry. Thank you very much. So this is what the next time I'll prove sine 3x or theta, if I can say, cos 3x and tan 3x in my next video. That's the one I'm going to do. Okay? 3, my bad. I meant 3. Okay? Also here, I mean, okay, here is supposed to be, okay, it's supposed to be 3x. Okay, thank you very much. Thank you for listening. And so, thank you.